All right, let's jump right in. Every single time you click a link, type in a web address, anything, you are literally kicking off this invisible, super high-speed journey across the entire globe. It's a wild adventure that happens in the blink of an eye. And today, we're going to follow that click from the very start to the very end.
I mean, really think about it. We see that little loading icon spinning, right? But that's not just a waiting game. It's hiding this fantastically complex chain of events. So what is actually happening in those few milliseconds between your click and that web page popping up? That's the secret journey we're going to map out right now.
So before our little packet of data can even think about starting its trip, it needs an address. Not a street address, obviously, but a digital one. And this is the absolute first, most critical step. Your browser has to find the server's exact location on this huge, sprawling map of the internet. And the way it does that is with something called the Domain Name System, or DNS. You see, we humans, we're good with names, like example.com. We can remember that. But computers, nope, they don't do names. They speak the language of numbers. So DNS is that crucial translator that turns the name you type into the numerical IP address that the network actually understands. And honestly, the best way to think about this is like the internet's phone book. It is the perfect analogy. You don't memorize all your friends' phone numbers, right? You just look up their name. DNS does exactly that, but on a massive scale for every website out there. It's a really simple idea that makes the whole web work for us. So, how does this lookup actually happen? Well, it's this super fast 5-step dance. You type in the name, your computer pings a special server called a resolver and basically asks, hey, what's the number for this website? That resolver goes and finds it, sends it back to your browser, and boom. Your browser now has the exact address it needs to make the connection. All of this happens in just milliseconds. It's incredible. Okay, so we've got the address, we're golden, right? Well, not quite. We can't just shout our request out into the internet. No, it has to be packaged up, labeled, and prepared very carefully to make sure it gets to the right place and, just as importantly, can be understood when it gets there. See, this whole packaging process follows a set of rules, a framework really, called the OSI Model. And what it does is it breaks this massive task down into 7 distinct layers. Each layer has its own very specific job to get our data ready for the trip. And here's the really cool part. Your request starts at the top at the application layer, and as it travels down through these layers, each one adds its own little wrapper. It gets encrypted, session info is added, it's told how to be broken into smaller pieces, and finally, the addresses are slapped on. And that's the magic sauce that lets, your brand new iPhone talk to a server that's 10 years old without any problems. Each layer only cares about its own job. This is where that sending a letter analogy just clicks perfectly. Think about it. You write the letter, that's the application layer. You put it in a secure envelope, that's kind of like presentation in session. You write the full address on it, that's the network layer. And then the post office figures out the actual route, that's the last few layers. Every single step is absolutely essential for it to be delivered. So, our little letter is packaged, addressed, and in the mail. But the internet isn't just one big open highway. Oh no, it's a super complex web of different networks, private neighborhoods, and security checkpoints that our data packet has to navigate. Let's talk about the gatekeepers it's about to run into. A lot of the time, the first gatekeepers are proxies. These are servers that basically act as middlemen. And the key thing to know is who they work for. A forward proxy? That one works for you, the client, and often hides your identity from the server. A reverse proxy? That one works for the website's server, acting as a front door to manage all the traffic coming in. Let's stick with analogies, because they work so well here. That forward proxy? It's like your personal travel agent. You tell them where you want to go, and they handle all the details with the airline. The airline never even talks to you directly. The reverse proxy? That's the company receptionist. You just call the main number. You don't need to know the specific person's extension. The receptionist figures that out and connects you. Now, beyond these proxies, servers are usually organized into these little digital neighborhoods called subnets. Some are public. Think of them like the storefront of a building right on the main street, ready to welcome visitors from the internet. Others are private. They're like the secure back office or the vault, holding sensitive stuff like databases with absolutely no direct door to the outside world. This is a huge part of modern security design. Okay, so we've seen this incredible high-speed dance where everything works perfectly. But we all know sometimes things go wrong. What happens when the music suddenly stops and our data just hits a wall? You've seen this one before, I bet.
The dreaded 502 bad gateway error. It just looks like technical jargon, right? But once you understand the journey, it makes total sense. This is actually a message from one of those gatekeepers we were just talking about.
What it's really saying is that the company receptionist, that reverse proxy, it tried to patch your requests through to the right department, but nobody answered. The service in the back office was either down, broken, or just didn't pick up the phone. So the gatekeeper is telling you, hey, it's not you, it's them. I can't get through. So if you're the one trying to fix this, it's a checklist, really. You gotta ask, is the service even running back there? Or maybe it's just so swamped with requests that it timed out. Could a firewall be blocking the connection between the receptionist and the office? Or maybe someone just gave the receptionist the wrong extension number for the service. It's almost always one of those four things. All right, here's another classic head-scratcher for you. You can connect to a server just fine using its raw IP address, the numbers, but when you try to use its friendly domain name, you get nothing. It just fails. So what's going on there? That's a huge clue, right? It's telling you the problem happened way back at the very beginning. The journey failed before it even started. Your computer is trying to look up the name in the internet's phone book, but for some reason, it can't find the entry. The server's fine, the network's fine, but that initial address lookup, that's what's broken. And sometimes the problem is with the digital neighborhood itself. A server that's supposed to be public is stuck in a private subnet. It's like it's in a gated community with no roads leading out. To fix it, you literally have to build an exit ramp, an internet gateway, draw a route on the map to that ramp, and give the server a public address so people from the outside can find it. So when you kind of zoom out and look at the whole thing, it's just incredible. It's not just a bunch of technical steps. It's this beautiful, hidden digital dance that's happening billions of times every single second all around us. So let's run it back super fast. First up, the phone book. DNS looks up the name you know and finds the number the network needs. Then, your request gets packaged up perfectly, layer by layer, like a precious parcel. It zips past gatekeepers, finds the right neighborhood, and lands right on the server's doorstep. All of that just for your one click. It's pretty mind-blowing when you think about it. From a simple name to a number, through 7 layers of packaging, past gatekeepers and into secure neighborhoods, all in less time than it takes to blink. The whole journey is just amazing. So now you know what's really happening behind the screen. Makes you think, doesn't it? After all of that, what's your next click gonna do?